All right, so let's go ahead and practice. So here is my 30, 60, 90. So if I do it like that, this is 10, this is 10, this is 20. So this one is 20. And remember, from here to here, this magical number, based on what we learned here, is 10 times the square root of 3. This is a half square, so those are both equal to each other. And this one, based on what we learned up here, is 4 times the square root of 2. And if this, so to go from here to here, I multiply by root 2. That's the math that's kind of happening. So to go from backwards, I'm going to divide by root 2. So if I divide this by root 2, those are going to cancel and leave with me with an 8 on both of them. Now, this one is tricky. It's very purposely drawn not to scale, so you have to figure out what's really happening. This is 30, so this here is the short side. So to go from here to here, I am dividing by root 3. And when I divide by root 3, I'm not allowed to have a root 3 in the bottom, so I rationalize that by multiplying by root 3 over 3, which gives me 9 root 3. Root 3 times root 3 is root 9, which is plain old 3. And then I cancel. So that gives me 3 root 3 is what this side is. And to go backwards, if I take 3 root 3 times root 3, that's going to give me 3 times 3 will give me 9. So that works. Then I go from the short side, because this is the whole side and the whole side and the whole side. So this is 3 root 3. I'm going to multiply by 2, which will give me 6 root 3. So let's look at this one. 6, 6, 6 down here. So that means that this must be half. That's 3. And to go from here to here, I multiply by root 3. And finally, to go here, I am going to divide by root 2. I want to rationalize that denominator, which gives me 6 root 2 over 2. I reduce and I get 3 roots of 2. Now 3 root 2 times root 2 will give me 6, so I'm good to go on that. So let's go ahead and try these. What are we doing? And then find the area in the perimeter. So this is root 2, and this is root 2 times root 2 is root 4, which is plain old 2. This is 10, which is the hypotenuse, so this is the short side 5, because it goes like that. And this is 5 root 3. So the area of this is root 2 times root 2 divided by 2, so that's 2 over 2, which is 1. So that's the area. The perimeter is this plus this, so 2 root 2 plus 2. For this one, I have half of 5 times 5 root 3, which is 25 root 3 over 2 for area. Perimeter is 10 plus 5 is 15, plus the 15 root 3. And we're good to go. Okay, so let me put this lamp on, make this maybe a little better. So some of you guys asked for these guys. This was straight out of the book, but let's go ahead and look at this. This is 70 and 41. So to find this angle here, I would subtract from 180. So 180 minus 70 minus 41 is 69. And that is triangles equal 180. And then to find that one, I'm going to use linear angles are supplementary. So 180 minus 69 is 111. And then I can find this angle here, or vertical angle, 69 again. And then to find, so this is, vertical angles are congruent. And then I do 180 minus 69 minus 58. To give me 53, and I use triangles equal 180 again. All those cool tools I can use. So for this here, alternate interior, this is 47, so that is parallel lines imply alternate interior angles are congruent. And I can either use two things. There's something called the exterior angle theorem, that the remote interior adds up to the exterior. We did that proof long ago. You may or may not have remembered it. So I'm just going to do it so that I can do this quickly. 79. So that again is the exterior angle is equal to the sum of the remote interior. You could also figure out triangles equal 180 and then use linear angles. All right, we have our parallel lines here. So this is 127 because of corresponding. And then this one is, I get that right, 53 because of linear angles. So then then what can I do? I combine this one, 83. I combine this one, 53, using linear and vertical. So vertical angles are equal and linear angles are supplementary. And all four of those are going to have to add up to 360. So I can do 360 minus 83 minus 127 minus 53. So that would give us 97. And then minus 180 would give me 83. There's a lot of different ways you can do that, but that's what popped into my head, so that is what you get. All right, let's look at these. If these are both 45, triangles equal 180 gives me that this is 90. So if this, so not drawn to chaos. Okay, so this is your hypotenuse, crazy. And these are your two legs. And then this one is 3 roots of 2 using our information that we learned today. Okay, here's our last one. So for these here, I'm trying to figure out if they're similar. So this is the smallest one, and this is the smallest one. And this is the next biggest one, and the next biggest one. And this is the biggest one and the biggest one. So, what, 6 goes into both those 2 and 3. So it looks like these two are the same, but this one isn't. So this is not similar. This one here, 5 to 8, 5 to 8, 110, 110. So that would be SAS, similarity that works. And if I reflect that over kind of this line and then translate it over a bit, that would work. So that's the two things that that does. This one here, if I rotate that 120 degrees, I'm going to get that one there. And same, so it's all going to be in the same ratio. So that one is going to be SSS, similarity. And this one, I can use triangles equal, Pythagorean theorem to get that. And if I, let's see, if I flip it upside down, the 3 will be up here with the 6, but then I'm going to have to flip it again. So flip it over horizontally and then flip it vertically, and we should get our answer. Flipping meaning reflecting.